3 years ago, Lieutenant Colonel Joe Shahid, Air Force retired, made the best decision of his life, marrying Michelle. They met at the United States Air Force Academy, and they both had careers in the Air Force, so don't let Michelle undersell. A part of the Lebanese mafia, Charles, Joe Shahid grew up here, graduated from Bishop England High School. As I said, attended the United States Air Force Academy, class of 1990. He piloted KC-135s, the tanker jets, as well as the C-17s, and then went on and flew for Delta Airlines. After that great flying career, he made enough contacts and had enough networks around the country. He, being entrepreneurial, opened up his own business, Best Forensic Engineering. And if you're looking for the best forensic engineering, you know to go to the Best Forensic Engineering. And certainly his work is the kind of stuff that the people at the dockside probably are looking for. People would just take a look, make sure that their buildings are going to stay standing. So Michelle kind of talked about the family. Joe has a lot to talk about, so I don't want to take any more time. So Joe, Shahid, thank you so much for joining us.
Thanks for letting me come here and share this with y'all. So yeah, big memories with big coach, Big Cat. Mike Colley was my wrestling coach, huge influence on me. And you may not remember, we went fishing a while back when I was much younger with my dad.
Mike just retired from being school superintendent out there.
Yeah, I heard. That's fantastic. Hopefully he'll come back here, right? Okay, so what do forensic engineering? I kind of got into this in the Air Force a little bit. I was trained as an accident investigator. I've always been fascinated with figuring out the cause of failures and problems. And my background is in civil engineering and structures, and so what I basically, forensic engineering is kind of the use of that knowledge. I just apply that causation analysis to buildings instead of airplanes. Just as everyone understands the scientific method, basically the whole process is to gather the information that you need, create a hypothesis, get your evidence to support that, interpret that, follow the facts where the facts may lead. Don't let the facts drive, don't let your opinion drive the analysis, let the facts drive the analysis. Draw conclusions and publish the results. Of course, that's just one of the kind of basic scientific methods, and that's what we have to employ. But in my faith wise, I've learned that none of this would be possible if God had not created order in the universe. Because God's order, it makes the scientific method even possible. If there were not laws of nature, we wouldn't be able to recreate, experiments and such. So, even in Romans 1:20, St. Paul is talking about that. Of course, he's addressing this to folks who didn't quite understand, the concept of God. We could probably use a little bit more of this kind of quote in today's world, but ever since the creation of the world, His invisible nature, namely His eternal power and deity, has been clearly perceived in the things that have been made. So, if you can't see God, but you're looking at creation, you are seeing God. You're seeing Him through His creation. And so I try to use that I let my faith guide my values as far as my work, and I'm going to talk a little bit about that today through some case examples. And I don't want to get too caught up in some of these, but some of them are kind of interesting. I brought some of the more interesting ones with me. But this was a cantilever concrete wall, retaining wall collapse for a dark container facility that was being constructed in Lithonia, Georgia. This is basically the design. Not that it matters, but this is an interesting concept for a retaining wall. It's a little bit different. You see the bottom stem leg. The longer portion is actually on the inboard side, the loaded side of the dirt. So the dirt's going to go up on this side of the wall. A lot of times you'll see retaining walls, and the way they build them, the dirt will be on the other side with the longer stem acting as a sort of a retaining. But long story short, that was the question: is hey, was the wall not properly designed? We went through here's what happened. Very large structure. It was under construction. They had a lot of huge rainfall event came, basically washed in and collapsed a portion of the retaining wall. So we were hired to figure out, whose fault is this? Is this the designer? Did the contractor do something wrong? What's going on there? And we went through the analysis and found out that the wall itself actually was well designed. It was well constructed. This was the problem. This is the photo that kind of gives you the clue. The building is under construction, and I'm not, as I said before, you can kind of see the way that where they already put the roof decking on a portion of it, but not the full area. This area that you see on the right-hand side that's open was eventually going to be paved and covered. So the retaining wall was never designed to withstand water, any water load. So it was designed for the soil load only. And what ended up happening was that there's another picture of the thing. You ended up having this rainfall event during construction that loaded and saturated the soil, causing a surcharge that fractured the retaining wall. It wasn't able to keep up with that. Anyway, interesting thing there. This is another one way back when, Hurricane Katrina, 2005, I think it was. The Hard Rock Casino was being built. There was now back in Mississippi, back at this time, you could gamble, but the gambling had to be done on the water. It couldn't be done on the land because it was a vessel, had to be on a vessel. So they went to great lengths to construct the Hard Rock Cafe, or Hard Rock Casino, on the water, and the hotel portion and all of this entertainment was on the land, and right off to there's an overview of it, and you can see that here's the structure we were just looking at. There's the guitar, the giant guitar. They had a kind of a facility, a floating barge, moored permanently with a structure over the top of it. So it's basically like but it's in order to, be in compliance with the law. And so the building never opened. It had just been finished about 3 or 4 days before Hurricane Katrina. The governor was down there and they were breaking the champagne bottle and hey, yeah, we're getting ready to open up. So it was brand spanking new. Hurricane Katrina came through and wiped it out. So this is what it looked like after the event. And of course, this was an insurance claim. The thing was they were saying that the wind from Hurricane Katrina caused the barge to then bump into the building and create damage. And the insurance company was like, I think it might be flood. So we got hired down there because it's a different pot of money, the flood money versus the wind money. So we were there to kind of resolve the issue. And this is a side view of the barge. You can see the substructure of the barge right here. This is basically the floating portion of the barge. This is the steel substructure that sat on top of the floats that supported the floor. So this thing was pretty high tech. It was designed to these tanks or containers were designed to pump water out or pump water in to maintain a perfect level with the floor as the tide came in and out. So as the tide was going out, it would it would pump water out so that the floor would stay level with the entryway. It was very high tech, pretty cool. This is a view looking down on the barge. You can barely see it, but if you look close, you can see some of the slot machines, never been used. They were full of money. They had cops out there 24/7 because this is like Looter Central. But this would have been where the part where the mooring, if you will. This was the portion of the roof right here. You're seeing the roof of the actual shed structure that covered the barge. it was detached and sitting on top of the barge, and the barge was now sunk, into the water there. There's another view of that substructure I was telling you about. So next door was the parking garage, and it was three stories tall. The second floor of the parking garage, the concrete exhibited evidence of uplift force. Okay. Concrete great, in downward force tension, you can drive cars across it, but it's not too good going up. So we're looking at this going, okay, what's strong enough to heave concrete up? Probably not wind on an open structure where the wind's going to blow right through it. Probably water. So this is what it looked like looking land side. And in the off in the distance there were a couple of apartment buildings right across the street. So hey, went over there, took a look at the apartment buildings, went up to the second floor of the apartment building, and measured this from the ground level. What you're looking at here is see these little things in the wall? See how it's like a perfect line? What do you think that is?
The flood line?
It's not the flood. Yes, it could be a flood line, right? But of course, by now it's like normally a flood line is identified by dirt, detritus, things like that are deposited. You didn't really see that much, but what you're looking at here is this is where the furniture had been floating and banging into the wall. So that is a flood line. That was created by the furniture. So we were able to get a positive identification of the height of the flood level and kind of track it back, and it was quite clearly the barge floated up, detached its own roof, floated over the top of the moor, and then when the flood receded, that's what caused all the damage. All right, much silver case, a little roof leak up in Horizon East condominiums in Myrtle Beach. I got caught up there. This is the roof is a rubber roof, membrane, EPDM, for those who know what they're talking about on that. It is a pretty decent roof, but in order to protect it, they would cover it with this relatively large stone ballast. And next to the little penthouse stairs, that's a little stairway, little rooftop compartment for all the elevator equipment, the pulleys and stuff like that. I noticed a split in the membrane right there, and I thought, okay, what's going on? I actually had to brush some of the rock away to find it, but I found the brushed the rock away. I found the split in the membrane, and I said, this is interesting. It's about 4 inches wide. It's linear. It doesn't look linear there, but that's because the rubber had kind of stretched. But if you kind of stretch the membrane out a little bit, it was linear. And I said, this is interesting. It's perfectly in line with the treads of the stairs. So I asked around and I said, hey, has anybody ever been on your roof? And they said, oh yeah, a couple of months ago we had some work done to the elevator. And I went, oh, okay. Well, looking around on the roof, I happened to find a couple of these metal rails here, and written on it was Darka Elevator Products, Inc., Wireway, that's the Wireway. And I said, it's the exact same distance as the other thing, so it became pretty apparent. Of course, you can't prove it, positively, but it looked like they were probably carrying these things upstairs. One of them dropped down and slid and sliced the membrane, and they were like, uh-oh, let's put some rock over it and walked away. That was probably what happened there. Next one, moving on up to Connecticut. 2014, they had a fairly heavy snow event up there. So for Connecticut, if they're calling it heavy, it's got to be something. So we got called up because a warehouse had collapsed. This is what it looks like in winter in Connecticut. And we looked at this. This is the warehouse itself. It's a metal frame warehouse that's been there for years. So we're thinking, what in the world, why would it all of a sudden collapse? It's been there for years. What was the difference? Well, this is an overview of the structure. They had recently made some changes. They had built this addition you see outlined in blue. The thing outlined in red was the one that collapsed. And they had built this little side shed here, this little side part. Now there's an opening door on this side and on this side for large overhead doors. This was a little, kind of a place for them to store some extra stuff. But this was a kind of a relatively recent addition, within 5 or so years of the event. So looking in at it, we were looking at, measuring the snow, taking a look at the failure points. This is what the frame connection looked like at the top of these metal frame buildings. It's old, but it's not in bad shape. It has some surface corrosion. It's not terrible. But there was one on the ground, though, that failed. And this particular photo kind of gives you the clue as to what happened. Does anybody see, and again, kind of going back to my faith, I've noticed that, the world is full of patterns. If you can recognize the pattern, and then you may be able, you can solve some of these things by looking at the pattern of failure and what happens. And it's always a matter of trying to find the inconsistencies in that pattern. But looking here, if you kind of go back, you see this is the connection point. There's a bolted connection for the two frames. Here on the bottom is another bolted connection for a support brace at the bottom connection. If you go back to this one, you'll see that everything is the same except for that bottom piece right there, which would be this right here. Shear, the bolts are shear. This is on the right-hand side, well, when you're kind of facing that photo, this is on the side of the building that had that additional shed roof. And the shear gives you a little bit of a clue. It sheared on the right side, on that particular column. So we were able to look at it and determine that when the addition roof loaded up, the original building was not designed for that additional snow load on that side. It created some lateral force that loaded on the right-hand wall of the original structure, overloaded it basically, and caused the cascade failure from that. One of the things that kind of precipitated it was the overhead door in the center of that right-hand side was in my opinion, where it began, because that would have been the spot where the frame load would have been jointed. And that's where, if you kind of look back at the photo, that's where it kind of failed at initially.
Does your work determine which insurance company pays or who's at fault?
I don't want to know. I try not to get involved in any of
You
that.
don't have to.
No matter who hires me, I tell them you're going to get the same answer. I'm just going to follow the facts and tell you what the facts say. That's what I love about my job, is that it's like it requires a curiosity to the extent of crazy curiosity. Wanting to know and not stopping until I figure it out, kind of thing. But all I have to do is search for the truth. And if you think about it in our life journey, that's all we're doing. We're searching for the truth. So for me, it's perfectly compatible with my faith. My faith, to me, is a search for God. And my job is a search for God's truth in whatever instance or circumstance I'm put into. So it's kind of great. I don't have to sit there and play the lawyer game and any of that stuff. I just say, this is what happened. And I find that most people appreciate that.
Although, Joe, you do get, as you can speak, you do get called in for deposition, things like that.
All the
because you have
time,
to
yeah, all the time,
explain what you want.
to testify at trial and stuff like that, it happens. But I typically will lead the jury through my investigative process similar to this, what we're doing right here. And I try to turn it into a little episode of CSI for them, because most of the time you're just sitting there. So it's kind of fun. Okay, so here we are, Hurricane Francis, Poinciana High School down in Orlando, Florida. This is back in 2004, Hurricane Francis came through. It wasn't a particularly, I'll put it this way, for us it wasn't bad. But in some parts of Florida it was pretty dang bad. Poinciana High School had this is an overview of the high school. Well, it was, their gymnasium was a designated shelter during the storm. This is what it looked like after the storm. Catastrophic failure. So there you go, completely peeled off. Can you imagine being, inside that thing when the roof was off? Oh my gosh, that would be bad. Metal panel roof, so we were going out there to, again, figure out what's going on. And this is what it looked like from the inside. Just devastating. Roof literally peeled off. So this is how the roofs, if you don't know, this is how a metal roof is attached to what they call purlins. Those are the metal channels that you're seeing there. It's these little clips. They screw the clips down, and then the clips hook into the metal panels above. That's how it works. All this yellow stuff you're seeing is insulation. It's a blanket type of insulation. If you next time you're in a gym, you see that white baggy looking stuff. That's what that is. That's the white part is the vinyl face. The yellow part is the insulation. So we were looking at this, taking a look. Okay, they're measuring, kind of, tracking what the spacing was between these clips, because that's a big part of doing the analysis. Is how much hold down does the roof have? So you would look at these clips to figure that out. When we got to one near the edge, what are you seeing? What are you not seeing?
No clips.
There's a clip here, right?
Yep.
You see the clip right here?
There's supposed to be more clips.
Is there? So this is the edge. Now, understanding the way that wind works,
Yes, I
and, as a pilot, I'm very familiar with the way that wind flows over curved surfaces. The most pressure you're going to have is where the wind changes direction, because it accelerates, and the acceleration of the wind causes more. The faster the wind, the more force, right? So, were there ever clips here? Were the clips ripped out?
No. 'Cause
How would you know?
There's no
There's no
holes.
holes, right? Yeah. Okay, good. It's common sense. So I don't know. Who knows what happened? They're putting the roof on. Hey, we got to put this.
The Quentin time.
So this thing was kind of it was waiting to happen, waiting for the right storm. Or
Exactly.
It was the right storm.
So, Cheryl first.
Is this from lack of supervising on the job? All of this is pertinent to me, because I remember that horrible collapse of that condominium in Florida.
Yeah.
Right.
And
That's a
that was
slightly
ma-
different
That was a
thing, yeah.
maintenance issue.
Right.
But isn't this somebody didn't supervise?
Chances are, yeah. Chances are. Go ahead.
So, what I'm getting from this is that in our own homes, we need to check out our hurricane.
Yeah, you can do that. That's a great. Also, if you happen to have, depending upon the age of your home, you can. Most insurance companies will give you a pretty significant reduction if you happen to have certain
Yeah, they do.
components added, and the retroactive addition of those items is not crazy expensive. So if you're interested in doing that, let me know. We'll drum out a little business, but we can help you there. I've done that a few times. And sometimes even if you don't have all of the items that they're looking for, you only have a few, they'll still give you a partial reduction. All right. So South End Brewery, this is right downtown, close to home. I love old historical buildings. I do a lot of stuff with old historical buildings, and this one, interesting building, built in 1880 after the Civil War. That's kind of important to the story. They had a stone ledge collapse. This is what it looked like about 2 weeks before the collapse. They called me out there and they said, "Hey, we have a problem with our ledge. It looks like it's displaced." And I said, "Oh yeah, you need to get something underneath there to brace it right away, because it can go anytime." I said, "I can't tell you when." Because I went back through some of the historical pictures from Google Earth and whatnot, and it looked like it had been slowly displacing for about 10 years. But I said, it's gotten to the point now where I'm a little nervous. You guys really should brace it. And 2 weeks later, I got a call, and they said, "Hey, you remember when you told us that it was, you thought it might flop? Well, guess what? It did." And so this is what it looked like. This is what I saw 2 weeks before it collapsed. When I told them, "Hey, this is not looking good." Well, this is what happened on a Saturday night downtown Charleston about 9 p.m.
Oh,
Y'all know this is down on
Yeah.
East Bay and Queen. I mean, this is like, Harmony Central. That nobody got killed is a miracle.
Right.
This is such a busy corner, and people love to congregate on that little facade right there, in that little area. Had it been raining, I'm sure that somebody would have died, because people would have been hiding there, standing there.
Joe, when was this? When did this? I don't remember this.
09, I think.
Okay.
Wow.
9 years ago?
2009.
So 16 years ago.
So anyway, this is what it looked like. So they asked us to go and take a look at it and come up with a repair. So the first thing I looked at is I saw the granite arch. This is that little piece that one of the two that sits right here, you know, right? So here we go. We have a piece of that granite arch. That's the, you know, support. Really, this is kind of supporting the whole thing. This thing sits on top of a steel frame. This building is interesting. Built in 1880. It was kind of a hybrid between timber, which was the main construction, and steel, which is starting to become more mainline. But it was a big iron, really, not steel, but an iron post supporting these things. And I looked and I said, well, that's interesting. What's this hole here? You know, I got a little closer picture of it. This is what it looked like. It was kind of deep, kind of oblong. And I thought, man, that's super interesting. Nothing's ever been in that hole. It's filled with, partially with mortar or grout. So I went up to the second floor where they had not as big of a ledge, but a little bit of a build out. And notice, what do you see there holding, this is from the inside looking out. So that's the window looking outside. You see these big iron straps. They're about 4 inches, 5 inches wide, you know, 3 inches. So the iron workers would put these big straps in. They would stick down into the holes and hold it back, retain. So what we're looking at was a 120-year-old construction defect where the steel worker, the iron workers did not put the retaining leg, the retaining pieces back in, holding that back. And Mother Nature, and 120 years later, it just slowly rotated itself outward. Very, very interesting case there. I came to find out, and you know, you're always learning this kind of stuff, but interestingly, the masons and the iron workers, the masons at the time, wonderful craftsmen, but they were mostly black. And at a job site like this, they would literally put a campsite for the workers. They would be there during the duration of the construction. And in this case, the masons would have been in their camp, and the iron workers would have been in their camp, and you know, ne'er the two shall meet shortly after the Civil War kind of thing. And it would have required relatively close coordination between the two parties to say, hey, we're done, ready for the steel, or ready for the iron, you know, but it just didn't happen in this case. Still pretty amazing construction to last for that long with that kind of weight holding onto it. So anyway, I came up with a plan to strap it back in, and that's what it looks like now, prepared.
They wanted to keep it, the old.
Oh yeah, they put it all back.
Yeah.
But yeah, so I decided to make it so that you could have a 300-pound construction worker sitting up there, you know, eating his lunch during a hurricane when an earthquake hits. So if you want to go to the safest place in Charleston, go stand underneath that. Like it's never going to happen.
So that is no longer a widowmaker.
No longer would have. So back to something interesting. Lawrence First Presbyterian Church in Lawrence, South Carolina. Showed up. They were building a new church. They were using metal plate, wood trusses. You know, the kind of trusses you see with little metal plate connectors for the pieces. They were assembling it, and it collapsed during construction. Thankfully, nobody was injured or killed. That does happen, sadly. There was a big fight going on. The people putting the roof up were fighting against the people who were putting the walls up. And the people putting the roof up said it was the people putting the walls up. They cut the wall. They cut the wall. And I said, what? They said, yeah. If you look over there, they cut it. They cut the wall. You know, not supposed to be cut there. I went around and looked at it. Okay, that's what they were saying. Okay, they said basically the roofers were saying that's what caused it to fail because they cut the wall. And I said, all right, let me look at this. So I took a picture of it. Where are these two pieces of wood cut? Is this one solid wood piece that was cut? Clearly not. Look at the wood grain. It doesn't line up at all. This was not cut. So it was installed this way. So that's not great, right? The people who built the wall should have had at least one of those pieces going across full span. Doing this does create a joint. It does make the wall weaker. However, I started looking at the way the trusses were installed, how they were put on. You see these little pieces of wood right here? The little segments? We call them in the industry, killer cleats. And they use these to space the trusses. They cut them all to 26 inches. trusses are set 24 inches on center, and they'll put these pieces of wood to help stabilize them and keep them centered. However, if you're gonna use those kevlar cleats, you've gotta brace the crap out of the assembly to keep it from rotating, because those braces don't provide a significant amount of lateral resistance. And as you stack truss after truss after truss after truss, it's, you know, you're eventually gonna have some thermal, just general tension between the pieces, and if you don't brace it correctly, it will fall. I started noticing all the locations where they had, and documenting all the bracing that they did have in place, and then went back to the document that talked about how you're supposed to brace it. This one right here is the length of the subject building, and what you're seeing here, these red lines and green lines, are the pieces of bracing that were supposed to have been installed during the installation. The red X's indicate what wasn't there. So they barely had any bracing on this, not nearly enough to resist the actual loads that were going to be generated during the construction. So it was really a matter. It was, you know, this is also, you're supposed to brace the sidewall against, you know, those kind of forces, and they had a little bit of bracing, but where you see the X's, there were no bracing. So they really did a poor job of bracing the trusses during installation. That's probably what led to it.
So you concluded that the trusses started collapsing and that's what pushed the walls up?
Yes, actually pulled them
Right, pulled
together.
it.
Well, as they fell in, it kind of pulled
It was
them.
more of a roof problem, sort of.
It was an installation of the trusses problem. And my last thing here, I'm going to try to let you guys do a little bit of sleuthing yourself. Got called up to the Missionary Baptist Church in Union Grove, which is North Memphis, Tennessee, and a roof had collapsed, not just a truss, but a whole roof. This was the church that collapsed. The first clue to this is not in a photo. It's that right across the street was the new Missionary Baptist Church. This was the old building that they weren't using anymore. It had been there and kind of unused for quite a while. This is what it looked like from above. Not in bad shape. You know, there were no, I did a weather research, no storm events, no wind to speak of on the day of the collapse, anything like that. Nothing that, no outside force. So I said, this is super interesting. So this is what the trusses would have looked like, you know, and the center approximate 30 trusses just pancaked. So this is what it looked like from the inside, and part of my job is super fun. I get to crawl through the wreckage and try to figure it out. So this is what it looked like from the end of the trusses. So I started kind of working my way back through there. Notice that these trusses are connected not with those metal plates like the standard ones, but this is an older building, so these would have been connected with these metal plates. All the joints would have been connected with just a single bolt to the metal plate connection. Most of these connections are in compression, so it's not a problem to do that, but it's just a different style back then. This was a example of the plate and how it worked. And kind of working your way back through, I noticed that several of them had the tear out pattern, right, where there had been a bolt there, and it pulled through. This is the king post. This is that vertical piece that comes from the ridge. So that means it failed in tension, right? It got pulled. And you can see the outline of the plate where it had been sitting there for decades and decades. You know, and kind of, it just left an impression. So then all of a sudden I got back to around the centermost, maybe trusses, I think 15 through 20 or so. And that same center post was there, but no, there's a hole, but no, the pattern changed. It went from a pull through where the wood was literally ripped out to the wood is intact with no removal, right? What does that tell you?
Screws removed.
No bolt, right, yeah, no bolt, yeah. So I started digging through the rubble underneath. There's the plate that one one of these 7 plates. And I said, well, that's interesting. If you look closely, there's evidence of having been there. Then I found that. So that's clue number 3. What do you think happened?
Bolts were
We
there.
weren't-
Exactly.
They used it on the building next door.
Yeah, the bolts were there,
Trying to
the
save
nuts
the
had been there, the nuts had been backed out, the bolts had been removed from the
Ugh.
centermost part. Whoever did this literally took his own life in his own hand. I don't know what they were thinking.
I mean,
It's crazy that this stuff happens. Unfortunately, it does, but I mean, it's my job to figure it out and follow the facts. So somebody had gotten up there and decided that this building is, we don't need it anymore, but we need the insurance money more.
Oh.
And so they went up there and they said, I can take care of this. And they unbolted the building, so that's how it works. So anyway, this is my company, Best Friends Engineering. My son came up with the logo. It's kind of cool because what does that kind of remind you guys of a little bit?
Yeah.
The Eucharist, the cross, and other things there. Kind of cool. But anyway, this is what we do, and that's my ride.
There you go.
But I appreciate y'all's time. Any questions?
Joe, thank you so much.
sure.
I think we have time for one question.
I don't think I have one for everybody.
I think that's cool.
Yeah, there you go. Sorry. Anybody else?
I'm not good at Air Force.
I know, right? Put 'em on your phone.
Sorry, oh, there you go, go ahead.
Is,
Got the
you ever
curve,
go
I'll
to a
figure out
job
the
and
curve.
there's just you just can't find a compelling story like you're finding here or trail? You ever find yourself,
Sometimes, yeah, no.
maybe it just was the snow.
Sometimes they have to throw in the towel and say, there's not enough evidence.
Yeah, yeah. That's not a loose bolt, though, that I.
So, just to be respectful of everybody's time here, I'm sure Joe will be able to, answer any questions afterwards. And, by golly, I mean, I have to say that if you were to do that in front of high school kids,
Oh,
you would have a lot more engineering.
Yeah.
I'm good.
Actually, I gave a very similar presentation to Wando for several years.
Yeah, that's fantastic. Thank you so much.